Good morning. I'm Mr. Srinivas Murthy from Yashil Chemistry Academy for CBSE 12 Chemistry. Today, we'll do some numerical based on Raoult's law. One is Raoult's law on a solution containing two or more volatile solvent. Second one is Raoult's law for a solution containing a non-volatile solute and a volatile solvent. Let us start the numericals. Most of the numericals are taken from the past papers and from the NCERT textbook. Let us see the first one. Vapor pressure of CHCl3 chloroform and CH2Cl2 at 298 Kelvin are 200 millimeter mercury and 415 millimeter mercury. That is P0 CHCl3 is given, P0 CH2Cl2 is given to you. Calculate the vapor pressure of the solution by mixing 25.5 gram of CHCl3 and 40 gram of CH2Cl2 at 298 Kelvin. Also find out the mole fraction of each component in vapor phase. Molecular mass is given CHCl3 118.5, CH2Cl2 85. Sometimes in the board exam, they may not give the molecular mass because you should know the atomic mass of carbon, hydrogen, and chlorine. By knowing it, you can calculate the molecular mass here. Right. Now let us see how to find out the total pressure. First one. Second one is how to find out the mole fraction of each component in vapor phase here. Right. First, we can write down the formula. Partial pressure of CHCl3 equal to P0 CHCl3 into mole fraction of CHCl3. P0 CHCl3 is the vapor pressure of pure solvent CHCl3. Same way, partial pressure of CH2Cl2 equal to P0 CH2Cl2 into mole fraction of CH2Cl2. So P0 values are given to you. Mass is given, so I have to find out the mole fraction first. Once I know the partial pressure of CHCl3 and partial pressure of CH2Cl2 in solution, I can add both to get the total pressure here. So first step is to find out the number of moles of chloroform CHCl3 and number of moles of CH2Cl2. Number of moles equal to mass by molecular mass. For CHCl3, mass of CHCl3 is 25.5 grams. So 25.5 by 118.5. That is equal to 0.215 here. That's the number of moles of chloroform. Same way, number of moles of CH2Cl2. Mass of CH2Cl2 divided by the molecular mass of CH2Cl2. 40 by 85, 0.471. So total number of moles, add both number of moles of CHCl3 plus number of moles of CH2Cl2. That is 0.215 plus 0.471. That is equal to 0.686. Now I have to find out the mole fraction. Mole fraction of CHCl3 is number of moles of CHCl3 divided by total number of moles. 0.215 divided by 0.686, that is 0.313. Mole fraction of CH2Cl2, either I can write it as 1 minus 0.313 or number of moles of CH2Cl2 divided by total number of moles. 0.471 divided by 0.686, that is equal to 0.687. So I know the mole fraction, I know the pure vapor pressure. Vapor pressure pure solvent is known to me. So I'm finding out partial pressure of CHCl3. P0 CHCl3 into mole fraction of CHCl3. That is 200 into 0.313, that is 62.6 millimeter. Same way, partial pressure of CH2Cl2. P0 CH2Cl2 into mole fraction of CH2Cl2. 415 into 0.687, which is equal to 285.1. Now I add both, that gives you the P total. P total equal to partial pressure of CHCl3 plus partial pressure of CH2Cl2. 62.6 plus 285.1, which is equal to 347.7 millimeter mercury. That is the first part here. I want to find out in the vapor phase, that is how much of the mole fraction of CHCl3 and CH2Cl2 in vapor phase. First we have done in solution. What is the total pressure of the solution? I am going for the vapor phase here. Vapor phase, mole fraction of CHCl3. Why CHCl3 equal to partial pressure of CHCl3 divided by total pressure in the solution. So 62.6 is the partial pressure of CHCl3. Total pressure is 347.7. So 62.6 by 347.7, which is equal to 0.180. And vapor pressure of CH2Cl2 either 1 minus 0.180 or partial pressure of CH2Cl2 divided by P total. 285.1 by 347.7, which is equal to 0.820. So this is the first one. Second one, we'll see now. Vapor pressure of two solvents I'm taking here. Pure liquids A and B are 450 millimeter mercury and 700 millimeter mercury respectively at 350 Kelvin. Find the composition of the liquid mixture if the total pressure is 600 millimeter mercury. Total pressure is given. P naught A and P naught B is given to you. P total is given. So I have to find out the mole fraction of A, mole fraction of B in solution. Then find out the composition vapor phase. That is Ya and Yb in vapor phase here. So what is given to me is P naught A 450 millimeter mercury, P naught B 700 millimeter mercury. P total is given 600 millimeter mercury. Better write down whatever is given to you. That will give you an idea how to proceed further. Moreover, whenever you do the numerical in CBSE, write the formula clearly, show the substitution clearly. Then you may not lose much marks even if your final answer is wrong. Out of two, you'll stand a good chance of getting 1.5 marks here. So be careful. Write the formulas clearly. Don't take it into consideration that everything is known to the examiner. They look for these steps here, right? So P total equal to 600 millimeter mercury. So P total equal to P naught A in the mole fraction of A plus P naught B in the mole fraction of B, which is equal to 600 millimeter mercury. I know mole fraction of A plus mole fraction of B equal to 1. So psi A plus Ib equal to 1. So 450 mole fraction of, vapor pressure pure solvent A. So 450 into mole fraction of A, psi A, plus 700 into 1 minus psi A equal to 600 here. So I got an equation 450 psi A plus 700 into 1 minus psi A equal to 600. By solving the equation, I can work out the value of psi A here. By solving the equation, I can find out the mole fraction of A, which is 100 by 250, which is 0.40. And mole fraction of B is 1 minus 0.40, 0.60. So this is the method of finding out the mole fraction of A and B in solution. I'm going for the vapor phase here. In vapor phase, Ya equal to partial pressure of A divided by total pressure here. That is P naught H IA by P total. 450 into 0.4 by 600. That is equal to 0.30. And YB is 700 into 0.6 by 600, which is equal to 0.70. Or you can write it as 1 minus 0.30 here. Next is calculate the mass of non-volatile solute, which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. Molar mass of solute is 40, molar mass of octane is 114. I want to find out how much of solute I should dissolve to reduce its vapor pressure to 80%. Let us say P naught of the solvent is 100. After adding the solute, it has come down to 80 here. That is, its vapor pressure is reduced to 80 here. So P naught 100, P 80. I can take it as mass of solute added is X here. Mass of solute added is X here. Molecular mass is given. So number of moles of solute is X by 40. We are using the formula P naught minus B by P naught equal to mole fraction of solute, which is equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. Number of moles of solute, I found out mass of solute X divided by molecular mass of solute is given 40. So X by 40. Then I want to find out number of moles of solvent. Here octane is used as a solvent. Mass of octane is 114. Molecular mass of octane is also 114. So 114 by 114 equal to 1 here. So number of moles of octane solvent is 1. Solute is X by 40. Total number of moles is X by 40 plus 1 here. Then substitute the values. P naught minus P by P naught equal to mole fraction of solute. That is number of moles of solute divided by number of moles of solute plus number of moles of solvent. Number of moles of solvent is 1 in this case here. So 100 minus 8 by 100 equal to X by 40 divided by X by 40 plus 1. Now solve the equation to get the value of X. X equal to 10 grams here. Here look at the number of moles of solvent is not neglected. Number of moles of solute in the denominator is not neglected when compared to number of moles of solvent here. In case you neglect, you will get the answer as 8 grams. So it is better not to neglect the number of moles of solute which refers to number of moles of solvent in the denominator. Take it as X by 40 plus 1 and do the numerical. X equal to 10 grams because the textbook numerical answer given is 10 grams. So they have not neglected the number of moles of solute when compared to the number of moles of solvent here. Vapor pressure solution containing benzene and toluene is 180x plus 120 millimeter mercury. Expression is given to you. Where X is the mole fraction of toluene, find P naught benzene and P naught toluene. See here you imagine a graph here that is vapor pressure versus mole fraction. Left hand side, of course, y-axis vapor pressure, x-axis mole fraction. Left to right, I can say left hand side, let us say mole fraction of benzene equal to 1. Right hand side, mole fraction of toluene equal to 1 here. So the right extreme, if you look at it, mole fraction of benzene is 1. In that case, toluene will become 0. Left extreme, if you look at it, mole fraction of toluene equal to 1, benzene become equal to 0. So I'm considering like this. I'm doing the equation. The total pressure is 180x plus 120. X is the mole fraction of toluene. So P naught benzene into mole fraction of benzene plus P naught toluene into mole fraction of toluene equal to 180x plus 120 here, right? Let us say mole fraction of toluene, I'm taking it as 1 here, right? Mole fraction of toluene, I'm taking it as 1 here. In that case, mole fraction of benzene is 0 here. So x equal to 1. 180x plus 120. X shows the mole fraction of toluene here. That's what is given to you. So x equal to 1 in this case here. So I can P naught toluene, what will happen? Mole fraction of benzene is 0. So P naught benzene into mole fraction of benzene becomes equal to 0. P naught toluene becomes equal to 180 into 1 plus 120. That is equal to x equal to 1 here. That is equal to 300 millimeter mercury. I have written it wrongly. P naught benzene, P naught toluene respectively. Mole fraction of toluene, I have taken it as 1 here. So benzene is 0. So toluene is equal to 120 plus, I'll change it now, plus 120 plus 180 here. 120 plus 180, which is equal to 300 millimeter mercury. 300 millimeter mercury, right? So I've taken one extreme where toluene mole fraction is 1. So benzene mole fraction becomes equal to 0. So P naught benzene into mole fraction of benzene is 0. P naught toluene into 1. That is P naught toluene equal to 180 into 1 plus 120 here. That is 300 millimeter mercury here. Then I'm going for other one. Mole fraction of benzene is 1. So mole fraction of toluene is 0 here. Mole fraction of toluene is 0. So in this case, it is 120 here. It is 120 in this case because toluene is 0. So 180x becomes equal to 0. So here the mole fraction of, sorry, vapor pressure of here, we can take it as 120 millimeter mercury. 120 millimeter mercury. That is the vapor pressure of pure solvent here, right? Solvent. I have followed. Once again, I will tell you, vapor pressure of solution containing benzene and toluene is 180x plus 120 millimeter mercury, where x is the mole fraction of toluene. Find P naught benzene and P naught toluene. So we can write the equation first. P naught benzene into mole fraction of benzene plus P naught toluene into mole fraction of toluene equal to 180x plus 120. I'm taking two extreme cases. One is the left extreme in the x-axis, other one is the right extreme in the x-axis. Of course, y-axis gives you the vapor pressure here. So I'm taking the case 1 where I take the mole fraction of toluene equal to 1. That is in 180x plus 120, x equal to 1 here. In that case, mole fraction of benzene is 0. So P naught benzene, the mole fraction of benzene becomes equal to 0. P naught toluene into 1 equal to 180 into 1 plus 120. That is equal to 300 millimeter mercury. So vapor pressure of pure toluene is 300 millimeter mercury. I'm going to the next extreme. Mole fraction of benzene is 1 and toluene is 0 here. So 180x becomes 0. So P naught benzene is equal to 120 millimeter mercury here. Right? Next is a solution containing 1 mole of X and 3 moles of Y gave a vapor pressure of 550 millimeter mercury. The same solution containing 1 mole of X and 4 moles of Y gave a vapor pressure of 560 millimeter mercury. Find the vapor pressure of pure X and pure Y. That is P naught X and P naught Y. I have to find out. Total vapor pressure in two cases are given. First case, 1 mole X, 3 mole Y. Second case, 1 mole X and 4 mole Y here, right? Case 1, number of moles of X equal to 1, number of moles of Y equal to 3 here. So mole fraction of X is 1 by 1 plus 3, 1 by 4. Mole fraction of Y is 3 by 1 plus 3, 3 by 4. So 1 by 4 P naught X plus 3 by 4 P naught Y equal to 550. I'll multiply the equation by 4. P naught X plus 3 P naught Y equal to 2200 millimeter mercury. Then I go for the second case here. I go for the second case. That is, number of moles of X equal to 1, number of moles of Y equal to 4 here. So mole fraction of X is 1 by 5, mole fraction of Y is 4 by 5. So I can write the second equation, 1 by 5 P naught X plus 4 by 5 P naught Y equal to 560. Multiply the whole equation by 5. P naught X plus 4 P naught Y equal to 2800 millimeter mercury. So I got two equations. One equation is 3 P naught X plus 3 P naught Y equal to 2200 millimeter mercury. Second equation, P naught X plus 4 P naught Y equal to 2800 millimeter mercury. Now solve the equation. Equation 2 minus equation 1. P naught Y equal to 600 millimeter mercury. Now substitute the value either in equation 1 or in equation 2. P naught x equal to 400 millimeter mercury. Right. Now we'll do the sixth numerical. Vapor pressure of dilute solution of glucose is 750 millimeter mercury at 373 Kelvin. Find the mole fraction and molality of glucose in this solution. Right. So vapor pressure of solution is given 750 millimeters. I have taken a solvent water. I am adding glucose. It shows a vapor pressure 750 millimeter mercury. 373 Kelvin. That's very, very important. 373 Kelvin is 100 degrees Celsius. That is boiling point of water here. Boiling point of water is aqueous solution. So water is the solvent. Boiling point of water is 373 Kelvin. Achieved boiling point is nothing but the temperature at which vapor pressure becomes equal to atmospheric pressure. So the pressure 60 millimeter mercury. So P naught is known to me, P is known to me. So mole fraction of glucose I can find out. P naught minus P by P naught equal to mole fraction of solute, which is glucose. 760 minus 750 by 760, 1 by 76 here. That is the first one, mole fraction of glucose I found out. I want to find out the molality of glucose here, right? That's the next step here. So solvent is 1 by 76. So I can find out the mole fraction of solute is 1 by 76. So I can find out mole fraction of solvent. Because we know mole fraction of solute plus mole fraction of solvent is equal to 1 here. So mole fraction of glucose is 1 by 176. Mole fraction of water is 1 minus 1 by 176. So I know both the mole fraction, which is 70. That's what I have written here. So I can now write here, mole fraction of glucose is nothing but number of moles of glucose divided by number of moles of glucose plus number of moles of water. Mole fraction of water is number of moles of water divided by number of moles of water plus number of moles of glucose. Now I divide the mole fraction one by the other. That is mole fraction of glucose divided by mole fraction of water, which is 1 by 76 divided by 75 by 76, which is equal to 1 by 75, which is equal to number of moles of glucose by number of moles of water. So using this, I found out what is the number of moles of glucose by number of moles of water ratio here, which is 1 by 75 here. Then look at the what is number of moles of glucose by number of moles of water. 1 by 75 equal to mass of glucose divided by molecular mass of glucose into molar mass of water divided by mass of water. That is 1 by 75 here. Or I'm bringing down the molar mass of water denominator. 1 by 75 into 18 equal to mass of glucose by molar mass of glucose into 1 by mass of water. Right. Then I know molality. Molality is mass of glucose by molar mass of glucose into 1000 by mass of water. So I know the first one, mass of glucose by molecular mass of glucose into 1 by mass of water is 1 by 75 into 18. So multiply it by 1000 to get the molality. That is, I am multiplying this value now. That is 1000 by 75 into 18, which is equal to 0.741 mole per kilogram here. That is the numerical. First, I found out the mole fraction of solute. But then you find out the mole fraction of solvent. 1 minus mole fraction of solute is mole fraction of solvent. Then write the expression for solute and solvent. Mole fraction of solute is number of moles of solute divided by number of moles of solute plus number of moles of water. Mole fraction of solvent is number of moles of solute divided by number of moles of solute plus number of moles of water. Divide mole fraction of solute by mole fraction of solvent. That gives you number of moles of solute divided by number of moles of solvent here. Then that it comes to 1 by 75, which is nothing but mass of glucose by molecular mass of glucose into molecular mass of water by mass of water. Bring the molecular mass of water to the denominator. 1 by 75 into 18 is mass of glucose by molecular mass of glucose into 1 by mass of water. Molality multiplied by 1000. That is 1000 by 75 into 18, which is 0.741 mole per kilogram. Right. Vapor pressure of pure water is 12.3 kilopascal at 300 Kelvin. Calculate the vapor pressure of 1 mole solute in it. P naught is 12.3 kilopascal. 1 mole solute means 1 mole of solute in 1000 grams of solvent. Of course, water is the solvent here. So N solute equal to 1. N solvent is 1000 by 18, 55.56 here. So P naught minus P by P naught is equal to N solute by N solute plus N solvent. So 1 by 1 plus 55.56, that is 1 by 56.56 here. P naught is 12.3, P I want to find out. So 12.3 minus P by 12.3 is 1 by 57.56. Solve the equation to get the P here, right? That becomes equal to 12.08 kilopascal. A solution containing 30 gram of non-volatile solute in 90 gram of water has a vapor pressure of 2.8 kilopascal at 300 Kelvin. Further, 18 grams of water is added to the solution. Vapor pressure changed to 2.9 kilopascal. Calculate the molar mass of solute added and the vapor pressure of water 300 Kelvin here. So two things I have to find out. Molar mass of solute added, I want to find out. Vapor pressure of water, I have to find out. 30 gram of non-volatile solute is taken. 90 gram of water is added. That's the first case. We get the vapor pressure of 2.8 kilopascal. That is, vapor pressure of the solution is 2.8 kilopascal. I'm adding 18 more grams of water. Vapor pressure of solution changed to 2.9 kilopascal. Temperature is constant here, right? So case 1, 30 gram of non-volatile solute plus 90 gram of water. So number of mole, total pressure of the solution is, of course, pressure is 2.8 kilopascal. I'm taking molar mass of solute is X here. So number of moles of solute is mass of solute by molar mass of solute. That is equal to 30 by X here. Number of moles of water, that is solvent. Mass of water by molar mass of water, that is 90 by 18 equal to 5 here. So P naught minus P by P naught equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. So P is known to me. So P naught minus 2.8 by P naught is equal to number of moles of solute is 30 by X divided by number of moles of solvent is 5 plus number of moles of solute 30 by X here. So 1 minus 2.8 by P naught equal to 30 by 30 plus 5X. So by rearranging the equation, I can get it as 5x by 30 plus 5x equal to 2.8 by P naught here. 5x by 30 plus 5x equal to 2.8 by P naught. That is one I'm getting it. Second one, vapor pressure solution is 2.9 kilopascal. I added 18 more grams of water now. Number of moles of solute is same, 30 by x. Number of moles of solvent is 108 by 18, 6 here. So here again I can write 1 minus P by P naught. That is 1 minus 2.9 by P naught equal to 30 by 30 plus 6x here. 30 by 30 plus 6x. So by rearranging the equation, I can write it as 6x by 30 plus 6x equal to 2.9 by P naught. So two equation I got here. Two equation I got. First equation is 5x by 30 plus 5x equal to 2.8 by P naught. Second equation is 6x by 30 plus 6x equal to 2.9 by P naught here. So divide one by the other here. Equation 1 by equation 2. That is 5 into 30 plus 6x divided by 6 into 30 plus 5x is equal to 2.8 by 2.9 here. So x is the unknown factor here. Solve the equation. I get x is equal to 23 gram per mole here. That is the molar mass of non-volatile solute added is 23 gram per mole here. Now x value is known to me. Let's substitute. Take any one of the equation. Equation 1 I have taken. 5x by 30 plus 5x equal to 2.8 by P naught. X equal to 23. By solving the equation, I can get the P naught. P naught equal to 3.6 kilopascal. It's a good numerical, textbook numerical. After seeing it, after listening to my lecture, you try once again this numerical. Vapor pressure of pure benzene, ninth one, benzene at 300 Kelvin is 640 millimeter mercury. 2.175 grams of non-volatile solute in 39 gram of benzene gave a vapor pressure of 600 millimeter mercury. Find the molar mass of solute added. Molar mass of benzene is 78 here, right? So pure benzene vapor pressure, P naught benzene is given. I'm adding a non-volatile solute 2.175 gram in 39 gram of solvent benzene here. It gave a vapor pressure of 600 millimeter mercury. What is the molar mass of solute added? So P naught is 640, P is 600 millimeter. Mass of solvent added, I written it as solute. Mass of solvent added. Solvent added is 39 grams here. Right. So P naught minus P by P naught is equal to 640 minus 600 by 640, which is equal to 1 by 15, which is mole fraction of solute here. Right. Right. So 1 by 15 equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent. Number of moles of solute is mass of solute by molecular mass of solute. 2.175 gram of solute is added. So number of moles of solute is 2.175 by x here. Number of moles of solvent is 39 by 78, which is equal to 0.50. So I can write 1 by 15 equal to 2.175 by x divided by 2.175 by x plus 0.5 here. Right. So this is the equation I got here. By solving, so I can solve this equation, only x is not known to me. By solving this equation, I got it as 0.5x is equal to 32.625 minus 2.175, which is 30.45. So molar mass of solute is 60.90 gram per mole here. It's simple. P naught minus P by P naught is a mole fraction of solute added. So P naught is given to me, P is given to me, number of moles of solvent is also given to me. Number of moles of solvent is also given to me. Mass of solute added is given to me. So it's simple equation. Finding out the value of X, which is molar mass of solute, which is 60.90 gram per mole here. 10th one, 34.2 grams of sucrose and 36 grams of glucose dissolved in 81 gram of water at 300 Kelvin. Find the vapor pressure of the solution. The vapor pressure of water is 300 Kelvin is 30 millimeter mercury. Molar mass of sucrose, molar mass of glucose is given to you, 342 and 180 respectively. So here again, number of moles of sucrose, mass by molecular mass, 34.2 grams of sucrose. So 34.2 by 342, 0.10. Number of moles of glucose, 36 grams of glucose. So 36 by 180, 0.20. Total number of moles of solute taken is 0.10 plus 0.20, 0.30 moles here. P naught is 300 millimeter mercury. P naught value is given to me. So I can write it as P naught minus P by P naught is equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent here. Right. Okay. This is what is given to me. So P naught value is known to me. That is given as 30 millimeter mercury. 30 millimeter mercury is given to me. Right. Then I can write P naught minus P by P naught. That is 30 minus P by P naught is equal to number of moles of solute divided by number of moles of solute divided by number of moles of solvent. That is 0.30 by 0.30 plus 4.50, which is 0.30 by 4.80 here. 0.30 by 4.80. Right. This is what we have done. So by solving the equation, P is equal to 28.125 millimeter mercury. It's again simple equation. Writing the equation, substituting the values. All the values are known except P. So I can calculate P here. Thank you from National Academy for CBSE 12 Chemistry and Mr. Srinivas Vasudevamurthy. Next class, we'll see colligative properties, then numerical based on elevation of boiling point, depression of freezing point, osmotic pressure. Followed by another video I'll put it that we'll discuss the multiple choice question and associational reasoning question. Thank you all.